doing it. I can do this chart. Woo-hoo! That's all I know how to do right now. I have to remember how to do everything else.
Okay, so this is 7.384 is my problem.
Yeah, I can do this.
1, 2, 3, 4, 5.
What we just learned.
Oh,
That is just what we learned.
well, there's a lot more work involved. I think that's the other problem. I mean, well, and I think that's true for some other ones, but yeah,
3,
show me work.
7, 13.5, 13, 4, 11, 4.5.
Woo! Okay.
Do you remember how to do all that? Because I don't.
Yeah. So we probably.
I don't remember anything. Oh yeah, we need to make a formula sheet. Just guessing, you know.
All right, guys, we're going to talk about the one formula sheet to rule them all. Now, obviously, you could just bring all your formula and add the formulas we talked about. It's really just that 1 chi-square. There's no real formulas for the correlation. All from your calculator. But I think it's nice to go through the whole semester, basically. Now, chapter 1 was all definitions. You guys remember that far back? Almost 4 weeks ago.
Nope.
Chapter 2 is where we started getting to some more meaty stuff. And, you know, we had the little dinky formulas. I'm not going to make you, don't even write it down unless you use an older one. You don't have to do if you want to put it on your formula sheet, you can, but I'm not going to make you do this by hand, remember? And of course, if it was sigma, it would be n, but I mean, S is the one we use most often. So if you don't want to put it down, don't, because I'm not going to make you do it. Okay, there you go. Chapter 2, let's see. What else we had in there that we had formulas I said you could put down? The median, I think I said you could put something down for the median, but it's really just P50, right? And that's an idea, P50. Yeah, I think that's it for chapter 2. Put the z-score formula over with chapter 6 here in a bit. Then we got into chapter 3, which was probability, if I remember right. Yeah. Oh, yeah. And this is the one where you start to realize formulas are not always the first thing to go for. Some of you guys still don't believe me, and you try to do the formula at a situation, and it just makes it so horrible and wrong. When it's just you had to look and count. That's all you had to do. So I know you're not used to a math teacher saying that, but that's the reality. Formulas are often useful, but sometimes they're not the best thing to do. So we had our A or B. What was that one?
P of A plus P of B minus P of A.
Oh, I see. It took a while for people to get their formula sheets out. I cry a little bit. I hope to God people remember OR means add. Yes? I'm not done writing it, by the way. Yes?
Are you going to take points off and just like break it down by like chapter 1 formula, chapter 2 formula, chapter 3?
No. That's what I'm doing.
Oh my gosh.
By the way, everything I take points off for, there's a reason for it. And if you disagree, you can always bring it up with me, and I'll tell you why you're wrong. And then you have and. And is basically what? Or is basically add. And
Multiply.
is basically multiply. Good. Because thankfully there weren't that many people. There were a few people in the probability mini test that had all the right probabilities, but instead of multiplying them, they added them on that first problem. But the first problem was all about this and this, this and this. It was all multiplication, right? So But what is it really? It's probability of A times probability of
P given B.
given A. Or the probability of B times the probability of A given B. So A and then B. If I do it without replacement, it would be the probability of A, and then I throw that away, times probability of B given A, the thing I just threw away. That's why the bottom would get less by 1. If it was poker chips or something I was pulling out of the hat, that's where this formula, what it models. It models that idea. But we didn't use the formula when we did that problem, to be honest. We just were like, how many's left? Oh, that many, okay. And we did it. And then we got probably an A given B. Yeah. I thought some of you guys are looking at it like it's the first time you've seen it. Oh, we're learning that now?
Yep.
Sure. Some point would be good. Okay. So now we leave chapter 4 or whatever it was. 3, 4. Then we get into XP of X stuff, binomial stuff. Yeah. So then we have these kind of formulas. Mu equals sum of XP of X. What kills me is when I have an X and a P of X, and the people try to use N times P and shit. I'm like, there's an X column and a P of X column. That's the biggest giveaway in the world. I don't know which formula. Probably the one that's got X and P of X in. So don't make that kind of mistake. Come on. And then here, I don't know which way you want to write it, but you can write sigma is the square root that. Please, dear God, you can't have little notes that would tell you what to put on top of the columns. That is a note. It's not a formula. So that's for the general probability distributions. And then we got into the binomial distribution. We had 3 formulas for that, basically. It was the probability formula. That guy? Yes, ma'am. Totally. Like I was saying, you could write sigma or sigma squared without a big square root. Either way. It's up to you. No, this is chapter 4 still.
Can't write that on there.
Chapter 5 was the uniform probability. And just general ideas, continuous probability. There's no real formulas there. There are. I am not going to say all the shit I said before about the uniform mean and the uniform standard deviation. If you want to find those and put those in your formula sheet, you do it. I'm not going to script. I know I signed some problems that use them. I don't care. I just wanted you to know they exist and how easy they are to use, and then forget them. Chapter 6 is where we get into the heart of this class, really, is the z-scores. Once we learn z-scores, it seems like we just never stop using them, or the ideas related to them. So then we get, now I'm going to put this stuff down there. We get that one, then we get this guy. You could also put down this guy if you want. Just remind yourself that yes, you have to still do it, even if it's already S, which is not the right way to say it. So that leads to this guy here, which is really the same damn formula, but you can write it down again if you want to. You can even put a little star on it if you want to. That's really where we used it the most for the hypothesis test, but you know, it's up to you. Because the T would just be that, right? Again, further reminding yourself that yes, you do have to divide the S by square root of n. Just don't do that twice, right?
Okay.
I'm kind of doing this out of order. Sorry, these are all the same kind of ideas. Because then we have the confidence interval stuff, and then I'll put the p hat stuff in a bit because that comes after confidence intervals. Hopefully these all look familiar. Yes, ma'am?
What is mu subscript over mu subscript like
X bar.
X?
That is the mean of the means. So if I took two people at a time, took their average age, two people, average age, two people, average, did it for everybody, and then I averaged the averages. It's the mean. Thank you. That's the big thing I had earlier this semester. That's why the mean doesn't change, because the mean doesn't give a shit if you do two people versus one person at a time. Okay? So that's part of the central limit theorem. The mean of the means equals the mean. The mu. They're the same. I love it. Sigma sub x bar, the standard deviation of the means, changes. So it changes like that. I love it when a student does that. Well, it's just this. And I'm like, yes. That's the point I couldn't make earlier this semester. And he just was like, well, it's this. Ah. Hopefully everybody else is there too. Well, it's just, okay, good. Okay. So we're definitely not done. That's confidence intervals. And then we got to do test. All right, so then we have the only real new one is if you wanted to, you could actually put all the z-score formulas again. You could put z star on them, right? So I don't know if you really want to do that. Whatever. Blah blah blah. T star. Same formula, just with an S instead of a sigma. You can waste lead and space if you want to. It's up to you. By the way, you could bring in, 18 sheets of formulas if you wanted to, as long as they're only the ones we said you could have. I don't care. You don't have to fit it on a little index card. And then we got this guy. The real new guy here. Notice there's only one hatted one in this. Right? These guys are not hatted because I only use the hats if I don't know P. In the hypothesis test, I assume I know P. I'm going to use it then. Should. I'll use sample information when I have to. And then, of course, you got the one we just learned today. Whoa. That's going to be in the final? Yes, this will be in the final.
Are you also offering extra credit on the final?
Bonus questions, yes. There will be bonus questions. You can imagine the final exam bonus questions, so there'll be extra interesting. Huh? You can always come up and see. Of course. I can very quickly say, I ain't saying shit. But sometimes I can clarify. I mean, there are things I can tell you. But normally if it's bonus, I'm like, that's bonus. I ain't going to tell you shit. But you can still ask. It could be something, I said something weird and I can clarify or something. Yeah. Anything else that should be on your formula sheet that I didn't say you could? Anything I'm missing? I'm getting older. You never know. My memory's never been good. So, I don't know how long I can keep teaching. Yes? I hate that I've gotten old enough that you guys are like, yeah, I feel the same way. What's that?
Variance, you're not having the variance?
If you want to write, you mean this guy? That is variance.
Oh, yeah.
But, you know, like I said, if you want to write with a square without a square root, you can. I don't care. But, right? Variance is standard deviation squared. So if I have any standard deviation formulas, that automatically means I have variance formulas. Yes?
On the previous test, you said that a bonus is going to be like the formula T star, and you use a different formula. Does that apply to?
Oh, yeah, that's right. So if you want to, if you did that chapter 10 extra credit, you can add this formula. Is this the one you're talking about? If you did not do that section, I would highly recommend not writing this down so you don't see it when you're taking the final and go, oh my God, what the hell was that for? You know, again, it's up to you. I can only do so much for you. Yes? Yeah, let me give everybody. I'll give you all, because there's a couple on here I said we do in class, and then I, of course, forgot to finish number 11. Is that your stuff or somebody there? Oh, nobody's there.
You're so ready to break. Now that I have the formulas on one sheet, I should be golden.
I'm going to review it.
Oh. Yeah. If you want to put the mid-range formula up here, that's fine.
What's high minus?
So again, I only put this up here
What's high minus one?
in case I don't have any question in mind, but like if I ask a bonus question related to this equation, then it'd be great to have it. I'm not going to make you use this. Remember I told you that. I said after that first test, I'm not going to make you make those tables. Of course, we made a lot of other
At least
tables.
5 car?
So we're not going to directly use this formula, but just in case I ask something about the formula like I did that one time. Yeah, if you want to put the other one on there, that's great. But just don't, I put in parentheses something to remind yourself, oh yeah, I don't have to use this anywhere. It's not. So if you'll notice on the answer key, there's on the back. So number 11 is not finished. I was going to finish it when I got to the school and I printed out some chi-square charts so I could actually look up the thing, and then I forgot to do it. So number 11, I got the chi-square calculated. I just didn't look up the chi-square critical, the one that we got to see if we beat it or not. So we can look that up. I didn't give us an alpha though. That's a problem. Oh well. Those are so needy. I love the printer decided to grab the paper in a weird way, so it's kind of like. So I was like, whatever, it's working. So shit. Number 9 is actually I'm one of those data points. I used to be the 1.5 216. Thankfully, I've lost a little bit of weight since then. But anybody ever had Bronx pizza down there? It used to be better than it is now. It used to be, and it still is good. But I always thought, did they put crack in the crust or something? Because I'm like, every second day I had, I want some Bronx pizza. Shove it in my mouth. Yes?
Can we add this where it says prove that it's a valid probability of distribution that all probabilities are also 1?
Hell no. Sorry. It was a good question, but no. That's something you have to know. Right? There's two things. What you have to do to show it's a valid probability, you got to check to see if it adds up to be 1. And now everybody understands the way that just anything works is there's a requirement. If you don't meet it, you better explain why it's okay. I mean, that makes sense. So it's better add up to be 1. If it don't, you better say something about why it doesn't, why it's okay. You got to know it. You got to know that. So let's do you guys want to do, it's up to you guys, really. I didn't put this on the key, 9 and 10. Figure we can do that together up here on the board, and then I can just open up to whatever you want to focus on. Let me see if this guy is going to keep going or not. Where are you at? Where are you at? Oh yeah, you got some time. Where's the All right, so let's see. Number 9. Number 9 says, science assessment test sample of 37 male students at an average of 300.4 with S equal 15.6. All female students at a mean of 290.6. Test the claim that the mean scores are the same for males and females using all the steps. Okay. So what's the claim being made there? All right, now put it more in mathish. This isn't really a true 2 population because I don't take 2 samples.
Oh, okay.
So which population did I actually sample from?
Male.
The men. So I'm making a claim about their mean. So the mean of the men, I'm claiming that the mean of the men is the same as the mean of the women, which was what?
Whoa, 90.6.
290.6. I love it when people write down 300.4 equals 290.6. I'm like, no, that's not true. Right? I don't know the mean of all the men. I'm claiming that the mean for all the men is the same as the mean for all the women. Okay, I like it. What's 300.4? That is, what's 300.4? X bar for the dudes. I like it. So where's that? Where's that go? Yeah, it's the null because it has equal sign. So what's the high going to be? That's great. So how many tail tests will it be? 2 tail tests, because not equal to it, go either way. Okay, I like it. It would be 1 tail if that was greater than or that was less than, because then I only have one direction that I care about. I only care about one direction. Okay, so that's step A. Step B. What's the next step?
On your teaspoon.
Got to say what I'm allowed to use before I try to use anything.
Oh yeah.
So what are we allowed to use? Z or T?
T.
Why T?
We only know
1, 2. Sigma unknown, I like it.
We're giving this out.
And
greater than 30.
n equals 37, which is bigger than 30. Central limit theorem says do it. So this tells me I can do something.
On your teaspoon.
This tells me I have to use t-scores. If I knew sigma, I could use
C.
z-scores. I like it. T-scores were invented to cover my ass for when I don't know the real population standard deviation. Here we don't. Shit, so we better use the thing that was invented for that purpose. So step C is rejection region. So we're going to use t-scores. What's the degrees of freedom?
36.
36. Alpha is
01.
0.01. 2-tail test. So 2-tail 0.01, degree of freedom 36.
$2.71.
So negative 2719, positive 2719. So if T star is
Less than negative.
or greater than positive, we reject the whole. Support the high. Some of you guys don't draw a picture for the step, and then you say things that make no sense. I mean, if you drew a picture, you could look at it. Describe that shaded. Oh, it's below that. Describe that. It's above that. Oh yeah, there you go. Now it makes sense.
You switched to 7.
I did. Cool.
You end up in some miracle ending up with T-star is exactly equal to that. That would still be within.
I think this book says officially you fail. If I remember correctly, I can't remember that. It depends on which book you look at, to be honest.
Really, like, would that kind of depend on more?
See, that's why I put that hard greater, hard less. So if it equals, then we would fail. And I think that goes along with what this book says. But to be honest, it's sort of like saying that the weight of something is exactly 8.2 pounds.
Yeah, right.
Ain't gonna happen. Yeah, so you could be more precise with something, with your star or your looked up critical. You make those more precise and you can see one that wins. Everybody's good so far? What are we talking about it? What are we going to use to talk about it? What's going to be enough evidence? And then, of course, did we get enough evidence? That's the next step. So what do you got? X bar is, where'd it go? 300.4. S is 15.6. N is 37. So what do I have to do before I can make a z-score?
Change 6.
Good. So the new standard deviation will be the old one over square root of 37. You guys put such interesting shit in here. It's you just pick a number, throw it in. Sometimes, not everybody. That's n. It's always n. It's always divided by the square root of n. N is always a whole number. There's a number of things, right? So it is a discrete measurement. So if you catch yourself putting 3.08 in here, you got to go, wait, me, that doesn't make any sense. I don't know what you get there. 2.565? Any dissension? I don't know. I didn't do it. Alright, we got 6. So now I can make my T star. Is that cool? T star is our data minus the supposed middle divided by the new spread. Be like 3.9, 3.8. I could be really off. What is it? 3.82? Sorry, I just am excited. Is that about right? Is that yes? Okay. Y'all don't care. Y'all like, you're a math boy. I don't care. You said 3.8. Who gives a shit? I'm excited. It means my brain is working. What would I never ask you at this point right here? Who remembers? Unless I might give you some extra credit if you're able to do it, but I would never ask a p-value because the t-chart's not detailed enough to get a p-value by hand. There are a few people that did all the homework for chapter 8 and 9 using calculator functions, which I'm like, do you know me? Have you ever met me? So that's nice for the calculator that's able to get a p-value. That's nice, but that doesn't do anything for our understanding. Right now you're in class, we're focusing on understanding. In the real world, you focus on outputs. Yes, I understand that. Here we focus on understanding. So what does this mean? Where do we make it? Made it way out here. We're in the rejection region, which means, reject the hoe. Support the high. There's not 2 samples in this problem, though. That's the problem. I like it. Second. Yes, there's an entire population of women, and then there's a sample of men. And we're just comparing that one sample to the number we get for the women. You can't calculate T-star from chapter 10 because you don't know what S for the women is.
But this is the same. All female students have a mean of 290. That means that if the sample still have this is a mean, right?
I understand. You can't use, everything you use chapter 10's equation. But what did you use for S2 and N2?
Since the S2 is 0.
No, but see, this S can't be 0. You would need the one for the whole population of women, which I don't think every woman scored the exact same. You don't have that information. So I understand now. It basically, the way you did it, it became this formula. Yes, but that's because we can't use that formula. We don't know. All right. So how do I word the conclusion then? This is, I'm sorry, Mimi, what's up? You lied? Gosh. At least you're honest about lying. I don't know. That is refreshing in today's atmosphere. What was my claim? The hoe. That's really all I need to hear right now. My claim was the hoe. So what wording do I use? The one related to the hoe. I mean, I still have people not quite understanding.
Oh my gosh. I get it.
Oh.
Sorry.
That's all right.
No
one of my favorite sounds.
No wonder
It's one of my favorite phrases. The hoe is the claim, so I'm going to use the language related to the hoe. So we have
Okay.
We have found sufficient evidence to reject the claim, good, that the mean science assessment score for men is the same as for women.
So for something like that, I would do something like we did not find sufficient evidence to support the claim, which is basically just the opposite side of that. But
No. The claim is the hoe, and you never support the hoe.
no, I know we did not find sufficient evidence.
But if you can never support the hoe, then that means you can never fail to support it.
That's for them.
Does that make sense?
Don't confuse me.
What's the only two things you can say about the hoe? Reject, fail to reject. It's the only two things you can say about the high. Support, fail to support. That's it. I don't want to see the word accept anywhere. Yes, ma'am.
Walk us through again. How does the 3.82 like help support more?
All right. So the idea is that this represents 290.6. So I'm assuming that this is how the dudes look. Which means if this is how the dudes look, then any sample of dudes, it's very cool of me saying that, any sample of men should be close to that. What's close? Well, in this case, close turned out to be that. Anything inside there would be close to this, which wouldn't be evidence that it wasn't this. We got so freaking far away. Far away based on what this is, right? That's what far away enough is. We got past that. So it's more likely that the mean is not this. Instead of the mean is this and we just happen to get a sample way the shit out here, right? So that's the whole idea is, if I get a sample that is so far away from the middle, that must mean anybody that thinks it might be the middle must be wrong. And who always thinks it might be the middle? The null. I like it. Which is really, and I'm okay with this. It's the same thing I've been saying since the first day we talked about this, but you just got to go through it and really get it and get the details and then come back to the general idea and go, oh, I've done it enough now, I can relate to what the hell I've done and make sense. I'm hoping. It sounds like that's where you are now, maybe? Yes. Okay. That's what you always realize whenever a math class you're in. Realize that it does make sense. It just doesn't make sense to you yet. Just have that faith. It will make sense to me. All right, and then what? We got another one, right? Oh boy, that was just one of them. Oh yeah, number 10 is the one that uses the piat and the piece, right?
Did you?
So let's do that one real quick. If you desperately have questions on something else, I'm okay with doing something else. But I do want to kind of do this since I didn't put it in the answer key, but still.
Yeah, let's do that.
Okay. Blah, blah, blah. So what's the claim being made in number 10?
E is greater than 0.387.
Yep. We feel the percentage has increased from previous years, which is 0.387. Is that the ho or the high? Because it doesn't have equal sign.
I'm gonna get this one. Watch.
So what's the ho?
Less than it.
Notice how I did not put 38.7. The minute you start working in a problem, since we didn't make the equations ourselves, we have to make the numbers. We have to make the percentages numbers, make them move decimals. Let me see, blah, blah, blah. This is a 1 or 2 tail test?
One.
Yeah, 1 tail. What do I check to see Z? Can I use Z scores?
NP times.
Yeah, NP. What's N?
292.
292. What's P? 0.387. Right? That's P. Don't calculate P hat and use it there. I only use P hat if I don't know P, and a hypothesis test is all about assuming that we know this shit. Whatever the hell that is. Whatever it is, it's going to be bigger than 5. 20, what is it, 110, 113? 100? 113? That's bigger than 5, so this is going to be 179?
Yep, 178.
179. All I did was subtract it from 292, guys. Don't give me too many props. I mean, yeah. I'm amazing.
Yeah.
Blah, 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 blah. Okay.
That's greater than equal to. He did on the bottom.
Say again?
Oh,
You never use T-score
or percent.
for NPQ problems because we create sigma. We never not know sigma.
Never
That's
not
a
know
neat
sigma.
grammatical thing I just did. We never not know sigma. We always know sigma for NPQ because we make it. We make it, so we know it. So definitely a Z-score. Definitely. Because, what does this mean? What does this check we just did mean? What's it mean? Normal enough. All right, I see confused faces, but I don't hear questions, so I'm going to keep going. Okay. Now we set up our rejection region, yes?
Question on that. So when it says like Z-score, T-score, when you say Z-score, how do you want to say it's normal enough? Is that how you want to say it?
Yeah, this means normal enough. Yeah. So for a mean test, I have to say 2 things, because the first thing is, can I do anything? Is it normal? And then the second is, which do I use, Z or T? Here I only need to say one thing, because I can only use one thing. If it's normal enough, I use Z-scores. If it ain't, I don't do shit. So obviously I'm not going to do that, but you still got to tell me. You got to show me. Don't just say NP bigger than 5. Enough of you guys should have gotten that note from me by now where I say, show me, every damn word. Show me. Don't just say it. Show me that it's true. Right? All right. Missouri. C. So rejection region alpha is 0.09. So if you wanted to, you could use, is everybody cool with that? Alpha's 0.09? What happens?
No.
LOS, level of significance, 0.09. It says in the problem, right? Okay. And I tell you, you're going to have to get the p-value. You could actually just not use the z-score at all, to be honest. If I calculate the p-value compared to alpha, so if the p-value is greater than 0.09, what would I do? Let me say it this way. If it's less than 0.09, reject the hoe. I'm not looking for an apology. It was just a neat sneeze, that's all.
Why don't we find P value again?
What do you mean? I just said we are going to.
Oh, we are.
Yeah, in fact, it says in the problem, you will need to find the p-value. Now, if you wanted to, you can look up the z-score on the z-score chart.
Yeah.
Why can't I use the t-score chart?
Yeah.
Doesn't have this shit, right?
Excuse me.
If I do find the z-scores for this,
0.09.
I'm sorry, one z-score. So one tail test. 0.09 is going to be that tail, so what's going to be below it?
94%.
Yeah, so if you look up 0.91, what's the closest you can get? Do I have any z-score charts left? Ah. Maybe? Yes.
Negative 1.34.
Yeah, 1.34. Positive 1.34, because we're up here. So if z star is bigger than 1.34, we can reject the null. Right, if z star greater than 1.34, we can do this stuff. Either way. What happened? Right? What happened? What's up? Yes. Tail's up here, right? Greater? It's up here. If my z star is bigger than 1.34, then I can reject the null, support the high. Right? Again, I don't know. If anyone's confused out there, try to get to a point where you can formulate a question for me.
You can't.
Yes. Yeah. 0.09 in the tail, which means there's 0.91 below. So if I look up 0.91, the closest I can get is 0.9099, which is 1.34.
There's other values, there's like 0.9,
That's way too far away from 0.91. 0.9099 is pretty much 0.91. So that's the best one to use. Yeah.
Oh, okay. I think no.
Is that the part that you're confused about?
No. I was wondering why it was bigger than 0.1.
Because that's where the
Yeah.
rejection region
Yeah.
is, of course. Yeah. Okay.
That's why I didn't ask. I had to figure it out.
All right.
Yeah.
So, what are we talking about? What can we use to talk about it? What shows enough evidence? And now, of course, how much evidence do we find? What's p hat? Yeah, x over n. 0.418. Does that sound right? Yeah, this looks right. It's a little less than half. Yeah, 0.48 makes sense. Q hat, who gives a shit? Don't do Q hat. Don't confuse yourself. The formula just needs p hat minus p. We know p. Square root of pq over n. We can figure out q. So we know q. So my data minus the supposed true thing divided by square root of p times q over 292.
I don't want to do the math. Someone else do it.
Well, why are you trying to do that in your head, Jeff? Give yourself a break, man. 1.08? 1.08? Oh, 9? What's that, 8.5, 8.6, 8.7?
The hell?
Of course, because it was up on the board earlier. Yep. This guy was one of the formulas that was up over here? Yes. This.
Oh, 0.087.
I got to do something. To live in this world, you must know how to make percentages. You are surrounded by them all the time.
We cannot put X minus not X.
No, don't do that. In fact, I told you guys you couldn't do that for the other one. Some of you guys lost points for doing that.
Alright, so P value.
That is an idea.
Let's look at 1.09.
You could argue it's a formula, and then I'm just going to say, okay, so formula I'm not going to allow on the formula sheet. There you go. It's like class width. What is the p-value?
0.8621. Yeah, that.
No. 8621 would be the wrong way. I want the area in the tail that my z-star makes. 1 minus that.
0.1379.
Yeah, 1379.
Oh, I was by the way.
This man.
Okay, so every time like on test 3, I just completely gave up because every time I tried to put that in my calculator, I always got like a big ass number. And I don't know the proper way.
So, this has got to be in parentheses so that it knows that's the top. And do you have the one where the square root symbol grows?
No.
All right. So when you have this parenthesis, you do not close it until you get all this shit in there.
So,
That's, if you close it, you're out of the square root.
okay, so I put 292 inside
What are you
the
doing?
parentheses.
Yes, definitely. Otherwise, you come out of there. That explains why it's happening to you. So what did we manage to do? Did we manage to make it far enough? No, we suck. We only got to here. 0.1379 is bigger than 0.09, or 1.09 is not far enough away. We didn't get past 1.34.
No. No.
Of course. So, here's 1.09, right?
Yeah.
What's p-value? Is the area in the tail, not the body. So when you look at 1.09, you get that. You better do 1 minus to get that. And it's the shortcut that tells you why the negative one is the same as the